capturing 1, 2. The main question is, will there be echo this time? Sure hope not. Wonderful. Many thanks, David, to confirm that. So I'll give this a couple of more minutes and start at the hour mark. Almost there. And we are live. Hello there, my name is Florian, and in these live streams I would like to address some things that I would like to see changed in the F# compiler. There are going to be multiple sessions, and the first one, as this one, is going to be about the syntax tree. So thank you for joining me, and let's head in straight away. So the problem I would like to take a look at today is something I raised a couple of months ago, and if you have the following code over here with the question mark hinting at the dynamic operator, the AST captured for this is a function application that takes an ident x, but it takes a argument k as a function argument. The k is a string, and this is kind of weird because what originally was written there is not a string. So because it's a dynamic operator, due to the way that works, it will become a string in the type tree, etc. But from an untyped tree perspective, it shouldn't be a string. I mean, not straight away. It should eventually become a string. So if we take a look at the AST for this, a couple of variations I found. So we're going to focus on the main one, is like this application with operator dynamic that has that string k here. Let's try and figure out how to convert this into something that represents better what was written here. There was a suggestion in the thread, let's introduce a new syntax node, SynExpr.Dynamic, and that's also the title of today's stream. So the idea would be, let's try and have SynExpr.Dynamic to capture this, so we don't necessarily need to capture the question mark, but this is just its own little thing. It's its own separate node as a syntax expression, and then we'll take it from there and then build on over it. Before we get started, a little bit of promotion. I've somewhat in secret published a new alpha of Phantomus of the next major version. Phantomus is also a project where I contribute. There's a lot of good stuff coming for Phantomus, and what I want to say today is there's a pre-release alpha published. Phantomus tool was renamed to Phantomus, and the key thing is that it is really, really fast. It is twice as fast, maybe even faster for your code base. So I really hope that if you're already using Phantomus, it gives us a try, just so we know that there are no regressions. That's not really today's topic, but just be aware that good stuff is coming, and I'll be blogging about this in probably by the end of the week. So you'll one way or another you'll hear the news about this release, but I wanted to mention it before we start. Cool. So regarding Phantomus, this is also my angle of getting this information better represented in the syntax tree. Phantomus uses the syntax tree to eventually go back to formatted code. And if we look at what happens here, I'm actually not entirely sure how this is going to look like. You can see the type is losing the quotes because this is type as a string. We just print the string. The parentheses are kind of interesting because if you look at the AST, the parentheses are not mentioned. So this will just be an idents of J, ident for short for identifier. So there's no notion of parentheses. We'll probably want to tackle that one as well. And the K is just a string. So we really do some very specific logic that if it's that operator, then oh, this is actually not a string, but probably an ident, but let's just try and fix this at the root. I've already cloned my fork of the F# repository. I made a branch. I'm at the root here. I've already run the build command, so we can run the build cmd, and what we need is no Visual Studio. That triggers a build of only the compiler bits. So I already did all that to save some time, and we can just head into the IDE. We're opening the F# compiler service solution, so this contains just the compiler and not all the Visual Studio tooling. So what we're going to do first is dive in, like where should this the syntax expression node be. The compiler has some recent refactors. Don has been cleaning things up in the source in the root of the repository at F#. Long story short, we now have this folder syntax tree, which contains the files we had. If you look at the previous video, so this is the second live stream or the second attempt, and the previous video might have like a slightly different layout. That's just because there are little changes. But long story short, we're always interested in syntax tree. This is really my home within the compiler, so to speak. So this is really the object model that represents what you typed. And if we go and look at syntax expression, this contains a lot of different things that represent what your code could do. So like a for or for each, or like an array, a lot of different nodes. And we're going to add a new case to this to represent our dynamic behavior. So let me just go until the end. So quite a lot of expressions. And for now, we're just going to add dynamic. And the first thing, not entirely sure of the name, but let's just, I guess, go with, damn it, naming is hard. I'm actually not really sure. Sort of the subject, but let's just call it the identifier, maybe. I'll most likely pick different names, but what we see in the original construct, so the first bit is actually an identifier, so the ident over here. I don't quite know what to call x. It's, we're going to try like k as part of object x, so x is sort of the instance here. We'll get to that. I'll just go with identifier for now and maybe call this operation. But yeah, as I said, naming is hard, and I usually just submit my PR, and if the folks at the F# team want a different name, I'm totally okay with that. So let's just say that this is an identifier, and then let's also call it the operation. Kind of struggling, and I'm not quite sure if this, should this be an ident or something else, because in our example we can have a k. K is obviously an ident, but if we have this j, the j has parentheses, and the question is, should this be like a syntax parentheses expression, or Should it just be like, just an identifier with expressions? We'll get to that as well. And I guess if we look at the parser and see what's allowed or what's currently parsed as this, we'll have like a better idea what this really should be. So I'm not really sure if you can add spaces and that will still work. That does appear to be, but see, even here the item J, I'm not quite sure what the rules are, but we'll get to that. So this has an identifier, this has an operation, and let's also capture the range over here. And for now, let's just at our example here, this is not, this is all building up, and we'll get to that eventually, better documentation and whatnot. And yeah, this PR won't just be approved as is, so it's okay to just start with something and see where it goes. And then I'll go over, so this was the signature file. We'll need to match this in the implementation. I can see that I'm already getting a warning here. Dynamic isn't part of it. So if I scroll down and add the exact same thing over here, then we have our dynamic, and over here we'll need to add this match to get the range as well. So this is already a first bit. Dynamic range is M, and then I actually should put this just higher, just to do the same thing. So that's a good first step. Eventually we'll dive into the parser and see where we should create it, but let's first create a failing unit test to capture what we expect is going to happen. So if I go to the compiler service tests, there is a symbols file which will already have a couple of modules, one being syntax expressions, and I think that's going to be a good one for having our test. So these tests are all more or less the same. There's a code snippet, the AST is grabbed from it, and then the AST is matched to what we expect, and we usually assert a couple of ranges just to verify that things aren't regressing over time. So let me just go to the end of this module, and that's about it. So, and yes, I'll just copy paste this and change it until we get what we need. So let's just call this an expression dynamic. Let's say does not contain string, which isn't the best name, but again, let's just start with something and then improve over time. So actually our sample can be fairly short. What we get here is we're always going to have an implementation file which always has a module. In this case, the module is going to be an anonymous module, but you always have that. Then the top level declaration is an expression, and in here our expression itself is then going to be our SynExpr.Dynamic. Let's just do nothing with it for now and say that if it is this shape, it should already pass. Otherwise, prints that it's not valid AST. So depending on whether the F# compiler will build, so there might be an incomplete pattern match somewhere. We'll need to fix those first, and then the compiler could build. Yeah, exactly over here. Then the compiler could build. We could run this file, and we could see that we have our failing unit tests, and that's always the starting point. So for the we can see the syntax tree operations has a walk method that goes over expressions to see if there's a error. So what we usually had was a function application. So around that part, I would see what was actually happening and then sort of mimic the behavior that we had. So the function application in this case just walks over both expressions. In our case, as I think both are idents, we can just actually say that this is all good. There are no errors. So in this case, we'll just extend our dynamic over here. So I'm not 100% sure about this, but I'm guessing pure from a syntax point of view, this will always be correct, because if it's, if it created the dynamic node and didn't go into error recovery, then yeah, it will never reach this point. So pretty safe. This is okay. And then check expressions. This is where it also gets interesting. But we can see application is already putting an error. So without really knowing what part of the type checking that we're at here, it doesn't matter that much. I mean, we used to have a syntax expression application. Now this is going to be a dynamic, but it should, do the exact same thing. So from that point of view, we can be a bit loose with how things are resolved in the type tree. But at a certain point, when it is creating the right thing for the dynamic, we'll need to ensure that our newly inserted node is in the picture there. And we'll do the same over here. So we'll find next app, and then is it a simple argument? Yeah, I think in this case it's both going to be a simple argument. For example, a long indent could also exist out of multiple pieces, and that's more or less what we're having here. So if this ends up that the second part is an expression of any sort, then we should pass the expression. But yeah, in this case, there's going to be both idents, and then the idents are getting into here, and then ident and both long indents are going to return true. So it also feels quite safe that we just return the dynamic over here. The fun part is when everything works, when everything inside the compiler works, but then there's some little regression test edge case where something are still not adding up. But again, I'll probably be okay. This looks like a little bit of a similar call. So this is all the same. Yes, next file. So this is traversing the syntax tree. So this is helpful to find certain nodes. The syntax visitor base is used in editors and whatnot. So we'll need to find what is it doing inside function applications. And my guess is that it's going to, so in our case it is an infix, so this one might be a bit interesting, but the point is I'm not sure if we are diving into this. So I would say that we could look more what long indent is doing. Not entirely sure. So let's just double check. Long indent, it's not doing anything anymore. Yeah, pretty sure that's kind of what we want. Let's just add it over here. And over here, walking breakpoints. Yeah, pretty sure we're all again walking expressions, so maybe. So this is really walking the inner expressions, which I don't think is relevant here as well, especially if, you know, long indents and idents are ignored here. We can just add our cons there as well. Alright. And I think that was the last one, so now this should build. Okay, there we go. And because that build, I should be able to go back to my tests, run this, and see that it is still the old AST because we didn't really change the parser yet. Okay, and I get this from time to time that the test isn't running for some reason. It's kind of hard to report because it doesn't necessarily all of the time is happening. What I then do is a little trick. You sort of want to run everything inside the module, and for some reason that is being picked up. So we have one failing test, which is to be expected, and we can see the syntax tree that's in there is exactly what is currently the case. So our k is a string. Alright, and now comes the fun part. We are going inside the parser itself. So the parser is being processed by fsyak. And if we go into this file, let's say fsy file, so there's a lex fsl and a parse fsy. The fsy will take the tokens that were coming out of the lexer and then construct a syntax tree. And what we can do right here is look for Dynamic, and that already isn't constructed in this exact file. But I think we can look for a question mark, and we should probably be able to find that one more strictly. So here we have a question mark idents inside of a pattern. We're not really dealing with patterns, we're dealing with expressions, so we can look for the next. That's the pattern as well. And question mark option name. So this is another thing I actually want to address at some point, but what I believe this is if you go back to the online tool and you create an instance of a class or something, and then you enter an optional argument like this. That is, I believe, the long indent with the option true. So if we look at that AST, this is a let binding over here. We have the idents, a in parentheses, and then this has a long ident with true in it, and that's the x, and because there's a true in Phantoms, we know that we need to put a question mark before it. So that's what that means. So that's not what we're after, but this looks a lot like the thing we are actually after. So this will call make SynInfix, which is something that we'll find in syntax tree operations. It takes two expressions and it will eventually create a application where one is an infix operation and the other isn't, to sort of combine those things together. And that's actually our dynamic application over here, which we want to change into something else. So this could be a atomic expression. We'll probably want to see what that can be. So it could be a couple of things, which is kind of interesting. It could be multiple expressions, so from that point of view, as I mentioned, we should probably revisit our identifier here and just consider that this is a syntax expression, which is fine. Let's just update both of them. Let's take it as an expression, as it can be an atomic expression. And then going back over here, the second bit is a dynamic argument. Let's see what the rules are over there. So this is when there's a colon behind it means it's a grammar rule. And in this case, it can be an ident, which in this case is our k, for example. So instead, the ident is being converted to a string over here, and that's the part I'm not really agreeing with. And in this case, it could also be a type sequential expression, and that's going to be a lot more fun, I think. So it could be a syn expression typed, or it could be a expression itself. So what I believe that will then be is that you could have something like within parentheses, actually printfn. So this is a sequential, means two operations following each other, and that's indeed our sequential, which is the application, the printfn function we're calling, and the return of y. So this could all be part of our. Yes, thank you, Oliver. Sorry, didn't notice the chat. So it could indeed be an expression. So that's the conclusion we're making here. And I think the right-hand side actually also could be an expression, although it appears to be, that's a typed expression. Interesting. So the right hand side could also be an expression, which makes sense if you think about it. Yeah, let's just change that to an expression as well, because it is a function application that takes two expressions. So I actually should have, it should have been more obvious to me that the operation is also just an expression, because at the end of the day this was transformed to a function application which takes two expressions, so it makes sense that this is also an expression. I'm not sure if operation is then still a good word, but let's just roll with it for a little longer and change this as well to an expression. And what we can do now, instead of this being transformed, the ident to a string, we can just create, well, exactly that, an ident. So what we can do over here is called SynExpr idents, which I believe exists. So ident of idents, ident is going to return idents. So in that case, we can just, or is it going to return a string? It could be a string actually. So let's go and see. The syn constant probably takes a text, so because $1 represents the node over here, so the parsed token of idents, so that's going to be a string. And from that point of view, we should create an ident for it. If you look at the top, ident can be created by constructing a range. So let's just grab the range. The range was already extracted over here. So let's just grab the range of this first item token. We can use the right hand side helper function, give it the parse state and say we're interested in the first item here in the grammar rule, and then this is the exact range that we're after. And we can create an ident over here that just takes that string. So if we want to use ident, we use the dollar notation, so slightly different. This is the actual thing this grammar rule produces, and this is sort of the index offset you would use for the range helper functions. So we can take this, and I believe that will then actually already just do the right thing over here. So both now return the syn expression, but this is matching more what my expectations were. Then going back to this guy, so both are in here. We're interested in the full range as well, so we could say right hand side 2, another helper function. You can say give me everything from the first item till the third. This would then be the range of the entire thing, and we could naively just create a dynamic over here. The atomic expression will return a note, then $3 is also a syntax expression, and then this is the range, and then atomic expression, let me just double check what that really is. So it is a expression and a HPA, which is probably the high precedence token kind of thing. So I'm not entirely sure if this is relevant for the rest of the parsing. It might be, so it's returned over here at the end. Because this is also an expression itself, so we'll just need to grab that as well actually. So arc1 is the thing we're actually after, and this HPA1 needs to be returned to respect the other grammar rule. So each case here, well, a bit like a matched expression you would have, needs to return the same thing in each branch. So that should be it. One other interesting thing, because we changed dynamic arc, we'll need to check, is it used anywhere else? So we're in luck. In this case, it's only used in one location. Otherwise, we had a bit more to do. This returns what it originally did, so that will be fine as well. Let's just skim through the other usages of question marks. In this case, or syntypes, doesn't matter. This is the actual question mark and probably operator names. So it might be used, but it's not related to what we're doing here. And that was the end of it. So wishful thinking, this was everything. And if we now rebuild the solution, because we're changing the FSY file, we need to rebuild the solution. The editor doesn't pick this up as you would change a regular F# file. So we really need to force the FSYAC to do its thing again. This entire file is being transformed to an F# file. I'm not going to show it here, but you can see that in action in like the previous video. We went through it over there. Basically, it's doing all this grammar rule stuff, and we'll create what the compiler is actually using to impart the tokens to the syntax tree. And if we're grabbing this build, we'll then just run our test again. If this build's okay, then I'm already expecting some good news actually. Because we didn't do any significant check within our unit test, we just want to verify the presence of it. And if we now run all of these again, wishful thinking, it will already do what we want. So yeah, and there you have it, all green. So that's good. We could yeah, spice this up just a little bit. Let's just grab the range of this thing. Say, and dynamic expression. Let's just assert the range. Yeah, just for some sanity. Assert range is another helper function. In this case, we're starting on line 1, column 0. So lines are 1 based, columns are 0 based, and we're at the ends 0, 1, 2, 3. That would probably be that range over here. And I think I got everything. Yes, there we go. Just run it from here and see if that still works. Okay. Yeah, it didn't run the test. So I think if I run it like this, then it all works again. Yeah, there we go. So that was it. Job well done, one might say. And for like Phantom's point of view, we have the information in the tree. This will be in there, and we can sort of restore it as the right thing. However, what we might also want to do is, well, actually verify that this is now a ident. So let's change that as well. So not interested in the X, I'm interested in the range, and so then I'm expecting this to be an ident with a ID of K, and I'll just assert that the ident contains the key. Or equal, so let's get it in there. So no, that's not that. Yes. I need to grab the unit test back. And run it like this. Which it didn't do, and it's very strange, but if I run them all like this, unfiltered, then it seems to work. Okay, and now if you were to build the actual compiler and have some code where you really mimic is this dynamic behavior still working, then yeah, we would probably see that nothing happened and compilation fails. I wonder if that's easy to show. Maybe it is. Let me try something. What I usually do is I create a little unit test that runs the background check phase of the F# checker, and then you sort of go through a lot of phases of the compiler, including the type check, and that's an interesting one to verify if everything is okay. What I'll try to do over here, I'm not sure if this is going to work, but if you look at the artifacts, and let's just try and grab the compiler, the FSC DLL, so it's not being built over here. So that means that, building this doesn't produce the DLL I'm after, but maybe this does. So if I look over here, compiler services, it will contain the same bits, but I can't just, run the compiler from the exe from that. So I need to build everything from here, which I could, but that doesn't always work when my writer is open. So let us cheat and run that background test I was talking about. What we can do, and this is something, purely on my local machine, but we can sort of add a file, which I happen to have, and so I'll just copy this in, because I kind of know what we need to change from code. We would need to look into where is this dynamic operation used in the type tree and sort of correcting things from there. But it might be interesting to see, to sort of see this in a failing test first, that we're having problems. So I added my own file over here. So this should pop up somewhere, I hope. Usually works. Nope. Oh wait, it's not in the test project probably. Am I in the test projects? Yes, I'm in the test project. Why am I confused? So, compiler includes. Yes, double L. Okay, so these are just a couple of tests with some useful stuff that I tend to do as debug. And what I'm actually after over here is I've created an instance of the checker. I'm going to parse and check a file in the project, and that target file is just a hard-coded file called library on my machine. So we'll just open that file, create what we need over here. So there's nothing really in there, but let's try and replicate K over here, and just see that we get something. And I have to say I actually never used the dynamic before, so I'm just gonna hope that this is how you do it. But if somebody can correct me, please do. Good. Opening the command line, that same file. Let's just see what that does for that sample project. So I'm hoping to get like some feedback. Okay, object string does not support the question mark. This is where I'm just gonna admit that I don't really know how dynamics really work in F#. I'll try googling that real quick. That's a good trick. I guess I'm after a dynamic object, but how to construct one, not quite sure actually. So question operator, dynamic SQL. If David, if you're still watching and you know how to do this, please help. I have no idea. Invocable. Or is this like a C# thing where you need an object from somewhere else? It is the same as C#Dynamic. Yes, I believe so, but can't you like in C#? I mean, in C# you can probably tell it's a dynamic or something, or Or do you put something like this? Nah, it would be too easy. Also never use dynamics, as is a good thing, I guess, that we never use dynamics. Oh man, how to create a dynamic object in F#. I actually wonder, can you even do that? Objects, dynamic object. Ooh, that's nice. System dynamic objects. Would it be as simple as that? Of course not. Okay, I'm not really going to find what I'm after. Should have prepared this. Oh, maybe what's this guy? Operator. Expando object. That rings a bell. What's that again? None of the type expandable project string supports the operator. Huh. Yeah, okay. I'll just explain what I was going for. But imagine I have like a working file sample, then I constructed everything I need, like the project options. These are really the things your IDE is going to use. The source text would be, the actual file. And then you can sort of see whether the type check results are giving you anything. And in this case, it's, wouldn't have done the right thing from a type tree point of view. And then it would give a diagnostic. Or even if, we were having a working sample, the error message might be different, and that's sort of the point that we're going to chase. So what I was actually thinking of doing next is looking where is this dynamic being used later on, because at some point it's going to be like recognized. I mean, it should be recognized at some point and then later on transformed. So I'm not sure if it's op.dynamic. Let's go back to my tool. The first example indeed has operator dynamic. So I'm expecting at some point that this is being used within, maybe it's over here. This is being used as a way of the type tree, like, hey, if it is this op dynamic, then we need to, do something, or it's an application. If the dynamic is just a function application, then we'll need to trace down and see how function applications are being used. So I was actually somewhat expecting slightly different behavior, but if it's just a function application, we'll need to be sure that wherever application is being used, it is just being picked up, which could be even a bit more challenging. So my guess is, let's go to syntax tree operations, and I'm also going to spoil that we'll probably not find what we're after inside of this full stream, so it's going to be like a good start, and then we'll leave it somewhere half in the middle. Because the idea is that I do these things for an hour and see how far we get. Not go endlessly into these. There are some active patterns which ring a bell. Which are then being used in the type tree, and then that's sort of what we're after, because the the type checker will process the applications, and when it does, it needs to let's see if we can go to type tree, type tree operations, and it's so type tree I'm looking for is in there have been a couple of renamings, and which is good. Check expressions, that's more likely what we're after here. Fix operation. There's some active pattern that sort of tells you. So TC expression. At some point, our expression is going to be in there, and we'll have some sort of a pattern match where the expression is being checked, and then we'll just need to do the same thing as in that's happening for applications. So we're having the environment, having a stack guard, and then going into here, and we'll jump around a bit, and yes, this is what we're after. So a syntax application, HPA is true, so not sure HPA is true, so in this case let's just simplify what we had over here. Oh, great. I got a reply in the chat, thanks for that. Library. Let me just try and build that one more time. Expando objects. I'll get back to that, but thanks for the pointer. I'll definitely include that in the actual PR, something in some shape or form, to have like a type check test. But going back to the check expressions, this seems familiar. This is where we were bound to happen beforehand, and I'll just need to actually try and mimic, our dynamic to just fit in here as well, and then let it play out as it was about to play out. So just wonder what HPA is, and okay, the atomic flag, and then the atomic flag. Let's try and follow this through and see where it should eventually end up. And there's a delayed application. So this is a bit trickier than I was expecting, but we're in the right direction here. So it used to be an application, and it still is. And the question is this doing with infixes? So So it's not an infix. It's doing all that. Otherwise it isn't. So we're probably, there's going to be something different for when it is an infix. What I probably also should have done is one, properly set up the tests to like debug and see what the type checker is doing. And what also helps here, and especially if we're changing the syntax tree in order to verify what behavior we have, what I do is I go into this test, so it really is like a good thing to sort of debug things, and I go through it, and then you also go through it through the same test on the main branch, and then you can sort of compare and see what actually happens, because at this point it's all a bit speculation. And I mean, I can set a breakpoint here, but I need a working sample to get there, so it's getting a bit of a chicken and an egg thing, and I won't be able to get much further than that. But open the namespace and install the NuGet package. Okay, see. We can maybe try that instead. So as we're closer to the hour, let's just try and wrap up with that. So I needed a NuGet package. And thanks again for the comments and all the help. There we go. That's one. That's two. So there we go. Let's say it's an end. Who cares? Alright. Alright, K definition for K. That's good stuff. That's actually what we want. And this is at runtime, so building this probably works fine, which is a bit the nature of Dynamic. So this is interesting. Let's try and run that test I talked about. Thank you again for the feedback. So first off, we'll eventually get here, and then we'll sort of see what happens if we debug this. At the very least, I'm expecting this syntax expression to already be our dynamic expression. That should be the starting point. So this is the expando object itself. So library, we're first going to hit this one. This is a constructor call, and we're going to get there later on. So this is the application, but it's not what we're after right now. It's still the creation of that dynamic. And then next up is an item. So let me skip through, and here we go. The dynamic ident x and ident k. So now this is going to end up in the unmatched, and this is probably already going to fail, so that's good stuff. So tcd late. Let's try to see if it's late, and we already have an exception. And our exception says, yes, so it's an unexpected tcd late, and that tries to do the remainder of the file, and then we can sort of see the check results over here are diagnostics that it's, so the namespace interrupts not defined. Maybe I didn't save the file, and then this is actually our error of the type checker does not know what our new syntax tree node does. Um, okay, so that's good. So maybe try and end on a high note. Let me open my second instance of Writer, and let's open another project. I mean, this isn't world class compiler development, but there's just a lot of stuff going on in the compiler, and from time to time you sort of tinker with things, and you is a project file. Do we want to open a project? No, I want to open a solution. Is that going to be better? Use service. All right. Yes. So then you can see that this is the main branch. So I've added a little background to see the difference. And I most likely already, yes, have that same test file over here. So we can actually dig into it and then sort of see it is still indexing things. But we're going to go to check expressions. Check expressions, because we have check expressions over here, right? Check expressions, okay. Then check so maybe this is all because of the syncing and indexing. It is still loading, so that's why we're not seeing anything yet. Just give this a little more. Might be stuck in this case, so let me just try that again. Yes, better. So in the parser for checking, should be check expressions. Expression. Then I believe. So we had our breakpoint over here, and then I'm expecting to grab over here. And yeah, for a use case, as mentioned, we'll just have to try and do the exact same thing. So let me just try and debug that. Oh, and yeah, this is building the compiler first, obviously, and my main branch, unaltered main branch, wasn't that prepared, so it needs to build everything from scratch. But there we go. So we get the object that's being created first. Okay, and then we get our function application, which indeed is our x question mark k. And if we then go into what that actually does, it surprisingly is not matching our application over here. It is going straight through the late. That's interesting. It is a typed app. Was that by design? Maybe I did that in my sample somehow. It is a typed app, so that explains. So the SynExpr type is the expression on the right hand side, but wrapped as the type information is also part of the expression. I guess I did that because the whole thing would compile, which isn't a bad thing, but is definitely another scenario where we need to take it into account. So instead of having this, which there will probably be scenarios. Again, I'm actually just not enough familiar with dynamic objects, but there will be scenarios where you hit this part of the tree, and in case of a typed, so don't be confused with type apps of the function itself, which is there's a return type attached to it. So this will probably be unwrapped in a later phase, but let's just go with this for now. So yes, we can see over here this just gets unwrapped, and if we then go, we're grabbing into our application. So from that point of view, it's actually already very interesting to take a step back and to see if our untyped tree is being captured correctly as a typed, because I'm not quite sure that will be the case for us. So we could see where this is going, and then how the entire type checking is being done. Definitely good stuff, and at this point we kind of know that our dynamic operation just needs to follow the same code path as over here. So this is something that we would eventually fix, but I'm now more interested in what would happen from an AST point of view if we go through the tests again, and if instead we had our typed over here. So a couple of things would change. I'll actually copy paste that. Maybe it's a good second test, because I'm not sure that this would actually be getting typed as is. So maybe, but maybe not. It's already interesting to sort of stand there. So in this case, we'll have a module declaration of let, which has a single binding, and we're not interested in range. So this should be, yes, it's not recursive, but that doesn't matter as well. And there are bindings, there's a range. Okay, there's one binding, which in this case has an expression. That expression should be the typed expression. Okay, I think it is body, and then we can just do SynExpr typed. So the binding, we can sort of not we put wildcards all over the place, but just do this named. And if we look at this named, it's not called body, but it's called expression. So this is the thing on the right hand side on the equal sign, and the typed over here takes probably an expression and a type. Just waiting for information. There we go. And we can say that expression should be a SynExpr.Dynamic, and let's see if that passes as well. So I need. Alright, and we're just gonna assert pass if the AST shape matches. Alright, let's use tests. Okay, so that does work. It's probably when the parser is constructing the binding over here, it sees the type and it's that exact type information that it sort of wraps the expression with. So I shouldn't have been worried. This works with any expression. There's nothing really special about our dynamic, but it it's another green test, and it's a higher note to end the stream on. I'm going to wrap up here. This has been a lot of fun. Should have been slightly better prepared, but I also just want to be a bit honest that I don't know all there is to know about the F# compiler. I know bits and pieces. I have a starting point, and I'll continue working on getting the same thing happening in the type tree, in the type checker, and I'll eventually, if I found a solution that's acceptable, I'll maybe post a link on like Twitter or Discord in regards of I've found something and this is what we really had to change in the type tree. So I think changes will be limited, and this is all just a slight improvement and mixing things around, so nothing earth-shattering, but at the same time it's just enough to get your feet wet at the compiler, and yeah, as I said, it helps you with Phantomus. So thank you all for watching, and I hope this was interesting, and catch you next time.